Hello friends, welcome to my channel. Today I would like to discuss some exercise on limits from textbook Calculus and Analytic Geometry 9th edition by G.B. Thomas and R.L. Finney. Chapter 1 Limits and Continuity and the section 1.2 Rules for Finding Limits. I would like to discuss the exercises from the section 1.2 Rules for Finding Limits. Before going to the exercises, we can just understand the concept of limit and the basic theorem that we needed to solve the exercises. First of all, what is a limit? Informal definition. Let f of x be defined on an open interval about x0 except possibility at x0 itself. If f of x gets arbitrarily close to L for all x sufficiently close to x0, we say that f approaches the limit L as x approaches x0. That is, f of x is defined on an open interval about x0 and f of x can or cannot be defined at x0 itself. And if f of x gets close to L as x approaches x0, then we say that f of x approaches the limit L as x approaches x0. Or we write limit extending to x0 f of x is equal to L. Next, we need the basic properties of limits. The following properties hold if limit extending to c f of x is equal to L and limit extending to g of x is equal to m, where L, m and L, m are real numbers. First, sum rule, that is limit extending to c f of x plus g of x is equal to L plus m. Second one, difference rule, limit extending to c f of x minus g of x is equal to L minus m. Third one, product rule, limit extending to c f of x into g of x is equal to L into m. And fourth one, constant multiple rule, that is limit extending to c k into f of x is equal to k into L for any number k. Fifth one, quotient rule, limit extending to c f of x by g of x is equal to L by m, where m not equal to 0. Sixth one, power rule, if m and n are integers and limit extending to c f of x the whole power m by n equal to L raised to m by n, provided m by n is a real number. Combining these properties, we get the important two theorems. The first theorem is limit of polynomials can be found by substitution. That is, if p of x is equal to an x raised to n plus an minus 1 x raised to n minus 1 plus etc plus a naught, then limit extending to c p of x is equal to p of c is equal to an c raised to n plus n minus 1 c raised to n minus 1 plus etc plus a naught. This just substituting c instead of x. That is, limit of polynomials can be found by substitution. The second theorem is limit of rational functions can be found by substitution if the limit of the denominator is not 0. That is, if p of x and g of x are polynomials and q of x is a non-zero, then limit extending to c p of x by q of x is equal to p of c by q of c. Next, we can go to the exercises. Find the limits in exercise 1 to 16. Since the questions are almost similar, we are doing only alternate questions. First one, limit extending to minus 7 to x plus 5. This is a polynomial function, so simply substitution from the first theorem. So limit extending to minus 7 to x plus 5 become just substituting minus 7 instead of x, that is 2 into minus 7 plus 5. 2 into minus 7 is minus 14 plus 5 is equal to minus 9. Next, we can discuss the third question. First and second are almost a similar type of question, so we can go to third question. Limit extend to 2 minus x squared plus 5x minus 2. Minus x square is 2 square 4 plus 5 into x 2. 5 into 2 is 10 minus 2 is equal to 4. Next, limit t tending to 6, 8 into t minus 5 into t minus 7 is equal to 8 into t is 6. 6 minus 5 into 6 minus 7. That is 8 into 6 minus 5 is 1 into 6 minus 7 is minus 1 is equal to minus 8. Next question is limit x tend to 2x plus 3 by x plus 6. This is a rational function. We have to look whether the limit of the denominator is 0 here. 2 plus 6, 8 not equal to 0. So we can apply the second theorem, that is limit of the rational function can be found by substitution. Here just substituting 2 plus 3 is 5 and 2 plus 6 is 8. 5 by 8. Next one, limit 5 tends to minus 5 y square by 5 minus y. Again a rational function and the denominator, limit of the denominator is a non-zero. So we can just substitute, that is 25 by 10. This can be simplified into 5 by 2. Next question, limit x tend to minus 1, 3 into 2x minus 1 square. This is a polynomial function. So by substitution, 3 into minus 2 minus 1 square is equal to 3 into 9 is equal to 27. Next one, limit y tends to minus 3, 5 minus y the whole raised to 4 by 3. Again by substituting minus 3 instead of y. 5 minus 3 the whole raised to 4 by 3 is equal to 8 raised to 4 by 3. Now 8 raised to 1 by 3 is just cube root of 8. This is 2. And 2 raised to 4 is 16. 2 raised to 4 is equal to 16. Next we have a rational function. Limit h tends to 0, 3 by root of 3h plus 1 plus 1. Now for rational functions, just look to the limit of the denominator here. Limit of the denominator is 1 plus 1, 2. So non-zero, just a substitution. 3 by root of 3h instead of h 0. So 0 plus 1 is 1. Root 1 plus 1. Root 1 is again 1. 1 plus 1, 2. So 3 by 2. In next set of questions, we will see how to eliminate zero denominators of a rational function. Question, find the limits in exercise 17 to 13. 17, limit x tend to 5, x minus 5 by x square minus 25. This is a rational function. So we have to look the limit of the denominator. By directly substituting, we will get 5 square minus 25, that is 25 minus 25, 0. 0 denominator. So we have to eliminate this 0 denominator. Simply x square minus 25 is x square minus 5 square. A square minus b square form. That is a minus b into a plus b. X minus 5 into x plus 5. Simply we can write x minus 5 by x minus 5 into x plus 5. Limit x tend to 5, x minus 5 by x minus 5 into x plus 5. This gets cancelled. We get limit x tend to 5 into 1 by x plus 5. This is rational function. 0 denominator we eliminated. So 5 plus 5 is 10. This is 1 by 10. Next question, limit x tend to minus 5, x square plus 3x minus 10 by x plus 5. Again denominator minus 5 plus 5, 0. So we have to eliminate the denominator. To eliminate the denominator, we can just factorize this one. X square plus 3x minus 10 can be written as x plus 5 into, this is just x square plus 5x minus 3x minus 2x. X plus 3x is 5x minus 2x minus 2 into 5. This is just x minus x plus 5 into x minus 2. We can factorize this like this. So x plus 5 into x minus 2 by limit x tend to minus 5, x plus 5 into x minus 2 by x plus 5. Cancelling this, we get limit x tend to minus 5, x minus 2 equal to minus 5 minus 2 minus 7. If you have any doubt on factorization, I will show some other method to factorize. We have to write it in the form x plus 5 into. So just take this x square plus 3x minus 10. To find this factor, we can, one factor we already know, x plus 5. To find the other factor, we have to just divide. This is x square plus 5x minus 3x minus 5x is minus 2x minus 10. Here minus 2 minus 2x minus 10. We got the factor x minus 2. Next question, limit t tends to 1, t square plus t minus 2 by t square minus 1. Here we can factorize this as t minus 1 into t plus 1. And this one, t square plus t minus 2 is a t minus 1 into t plus 2. This is just t square plus t is t square minus t plus 2t minus 1 into 2. Or we can factorize in the same way as above. That is, we already know one factor t minus 1. So to find the other factor, t square plus t minus 2 divided by t minus 1 is just t into t square minus t. This is 1 minus minus 1. 2t minus 2 plus 2. This is 2t minus 2. The other factor is t plus 2. So cancelling, we get limit t tends to 1, t plus 2 by t plus 1. This is equal to 1 plus 2 is 3 and 1 plus 1 is 2, 3 by 2. Next question, limit x tend to minus 2, minus 2x minus 4 by x cube plus 2x square. By substituting, we get 0. Minus 2 cube is 8. 2 into 4 is 8. Minus 8 plus 8 is minus 2 cube is minus 8. Minus 8 plus 8 is 0. So we have to cancel. Just simplifying, we get limit x tend to minus 2. This is just minus 2 into x plus 2. Minus 2x minus 4 divided by x cube plus 2x square can be written as x plus 2 into x square, x cube plus 2x square. Cancelling, we get limit x tend to minus 2 by x square. This is minus 2 by minus 2 square is 4 equal to minus 1 by 2. Next question, limit u tends to 1, u raised to 4 minus 1 by u cube minus 1. To eliminate the 0 denominator, we have to factorize. Limit u tends to 1, u minus 1 into, to factorize, we can write u raised to 4 minus 1 as, this is just plus 0 u cube. Since it has no terms of u cube and u square, we can write this in this form, 0u minus 1. U minus 1. This is u cube. u raised to 4 minus u cube is equal to u cube plus 0 u square plus u square u cube minus u square. This is u square plus 0u plus u square minus u, thus u minus 1 plus 1 u minus 1. Factorizes u raised to 4 minus 1 can be written as u minus 1 into u cube plus u square plus u plus 1. Similarly, u cube minus 1 can be written as u minus 1 into u square plus u plus 1. Cancelling this, limit u tends to 1, u cube plus u square plus u plus 1 divided by u square plus u plus 1. Substituting 1 plus 1 plus 1 plus 1, that is 4 by 1 plus 1 plus 1, 3. Last question, limit extend to 1, x minus 1 by root of x plus 3 minus 2. This is an irrational function. So, in case of irrational function, just multiply and divide by the conjugate of the denominator. Here, the denominator is root x plus 3 minus 2. So, the conjugate is root x plus 3 plus 2. So, we have to multiply and divide by the conjugate. We get limit extend to 1 x minus 1 by root x plus 3 minus 2 into the conjugate is root x plus 3 plus 2 divided by root x plus 3 plus 2 is equal to limit extend to 1 x minus 1 into root of x plus 3 plus 2 divided by, this is a minus b into a plus b form, that is a square minus b square, that is root x plus 3, the square is root x, just x plus 3, b square is minus 2 square minus 4, it's equal to x minus 1 into root x plus 3 plus 2 by x plus 3 minus 4 is x minus 1. Cancelling, we get a limit extend to 1 root x plus 3 plus 2 is equal to, substituting 1, root 1 plus 3 root 4 is equal to 2 plus 2 is 4.